Alright guys, so this is what happened to that funny looking robot humanoid. Well now it is a leg, because I haven't finished, but this is just one leg of the crab that I'm going to be making here. So, how this works is, this is all connected up like this, and it's going to be able to rotate like so, and then it has two more servos there, so it'll be able to go up and down, so it'll have three levels of rotation. Okay, so that's what the famous DOF is all about, degrees of freedom. You have a lot going on here. Of course, if there's a leg in the middle, it won't be able to go that far over here, but it has a lot of room to go here in the front, as well as it won't be able to be mounted up here probably, because otherwise it's just not going to be able to do a whole lot of motion. So my idea is to switch this around and have this mounted on top here or mounted here, and then have the whole thing mounted underneath, so that this becomes the body of the crab, and then it can do all its moving and then going up and down. Potentially we may have to increase the length of this leg or whatever, but it all depends on how the code is going to be written for this thing. So this just gives you an idea of what it might be able to do, and then there could be all kinds of different adjustments. But what I like about modular systems like these is, especially when it comes to 3D printing, you don't want to be doing a lot of air time. So if you 3D print a part like this, the bottom will be printed really fast, and then it's going to take a really long time to do this. So it's always better to print it like this, and then it has a lot of it's going to be way faster to print it this way rather like this, because this does a lot of sort of air printing, and it'll basically do the bottom, and then as it gets here it'll do this part, and then the printer head is going to rush to the other side and start printing this part, then rush to the other side and print this part. But when you print it like this, it's a continuous motion going through from bottom all the way to top. So that's why modular systems like these are really intelligent to be built. For this, there's not a whole lot that can be done. There will be bits where you won't be able to do it because, for instance, this bottom face will be the fastest to be done, and then these pieces here will have to be done like that, and then the head will go over here, and it'll come back here, and it'll come back here, and actually it'll go through 3 different parts. So this is probably going to be a pretty slow piece to be built compared to something like this. But these are useful to keep a motor in place like that without there being any contact. So this is nice and fluid, but this is protected, but because it has 2 points where it is attached to, and then you have this bit here with this sort of bolt here. So this is better than just having a motor on one side doing all the work without having the support underneath. So this is why I like this kind of system here, rather than just having it hanging off there, because sometimes you can strip the motors after a while, like the gears. So yeah, that's my brief walkthrough of what I have planned for a possible leg. And of course this can go through many different iterations, and we can design parts like these to be able to better support the servo for the hip if possible. Yeah, so yeah, this is what I had in mind, and I've got a bunch of these parts. The biggest issue that I'm running into right now is that I'll be able to do this for 4 legs for sure, but the middle leg here, I won't be able to do exactly the same kind of setup as that, or if I am able to do it, it may not be exactly centered or exactly in between these two, and that may cause some issues with the code there. So anyway, thanks for watching, guys. This is the update, and I'll see you in the next one.